we'll move on to our first speaker, who flew in from San Francisco. His name's Oliver Cameron, and he's a Brit in San Francisco and has been working on self-driving cars for many years. Founded a company, angel investing, worked at a big one, and I think will take us through his journey along that arc. So with that, join me in welcoming Oliver. Here's his clicker, and you have notes there as well.
Excellent. Okay. Good morning, everybody. I don't think Nathan's doing enough. I think he needs to do more things. So it's great to be here. I'm here to talk about cars that can drive themselves. I want to do some audience engagement, as corny as that might sound. Who here has taken a ride in a fully driverless car? No one in the front seat? Okay, there's a decent amount of folks. I think if you rewound, I don't know, 5 years ago, that would be absolutely zero, or even 2 years ago. So to see a good number of hands here is very encouraging. There is a lot of excitement, rightly so, about LLMs and all of these other technologies that we're getting very excited about today. And again, rightly so, these are transformative technologies that are changing the world. But what if I was to tell you that there was a robot that was so good that it blended into the background with other humans and the humans could not tell it was a robot? What if that robot could reason like a human, could see the world like a human, that it could accomplish tasks like a human, generate revenue like a human? You might not believe that that thing is real, but it's real. It's self-driving cars, and it is now scaling, which is what I'm here to talk about today. So who am I? I have been building self-driving cars for the last 7 years. You can break it down really into 3 phases. Phase 1, I was very fortunate to get to work at an online education company called Udacity. Udacity was founded by an artificial intelligence professor called Sebastian Thrun. And Sebastian was also the founder of the Google self-driving car project. And Sebastian's mission was to democratize access to education with a real focus on things that just could not be found in most mainstream educational establishments. So we really focused on teaching the world machine learning, robotics, and eventually self-driving cars, which I was very fortunate to work on. And part of that project was building an open source self-driving car, challenges for the research community in machine learning, just engaging with thousands of folks around the world to just push the state of the art in this field forward. And then I saw all these students having all the fun, building self-driving cars all across the world. So I thought, why can't I do the same? So I started a company called Voyage, which was really my second phase in self-driving cars. And Voyage was predicated on a real frustration I had, which was that in 2016, it seemed that self-driving cars were just moving slow. And as the kind of foundery type, you want to change that, right? You want to make them go faster. And the reason it felt like it was going slow at the time was because it seemed like the list of companies in this space were trying to solve everything all at once. That self-driving cars needed to be at scale from day one, that they needed to be solving the hardest places from day one. So I took that frustration and founded a company to try and solve that. The way we tried to solve this at Voyage is by focusing very intently on a specific customer. We focused on senior citizens. As we all age, our ability to drive is just not as it once was. Our reflexes aren't the same, our vision isn't the same. So what if instead of giving up my car keys and not having access to great transportation, I could instead give up my car keys and have access to self-driving transportation? Built that company over 4.5 years, and just the adventure of a lifetime, working with some really incredible people on solving self-driving transportation. About 2.5 years ago, that company was acquired by Cruise. And Cruise was at an interesting point 2.5 years ago where it spent the last 7 years before that building really great technology, just science fiction effectively. But it was not a product, it was a technology. And the Voyage team was brought in to effectively transform Cruise's technology into a product, something that people used every single day, something that people loved, which again, self-driving transportation back then had not accomplished. So spent the last 2.5 years doing that. Actually, my slide with my name and title is wrong because I'm now unemployed. I left Cruise about a month ago for my next adventure. Okay, so the dream of a car that drives itself is one that goes back a long way. I was going to put in a video of the DARPA challenges in 2004, 2005, 2007. I know some folks in this room actually had a part to play in those challenges, but it turns out it goes back even further. I'm going to play this video.
Years ago, who would have thought that cellular phones would be as common as they are today? Well, we may be thinking the same thing someday about our next story. CMU's Robotics Institute is developing a car that can drive itself, and it's already being tested on the road. Money editor Bill Flanagan went along for the ride.
Todd Yoakum is behind the wheel of this Army ambulance, but the CMU graduate student isn't driving. A computer is. The machine watches the road through a video camera perched above the windshield and steers the vehicle itself.
We've had it up to 70 miles an hour, and it's driven autonomously for over 90 miles straight without the human ever touching the wheel.
That's right. This robotic vehicle is driven to Erie and back on I-79. It's the result of 8 years of military research at CMU's Robotics Institute. Scientists here don't teach computers how to drive. Instead, they use a computer process called a neural network to create a machine that can learn to drive. Dean Pomerleau is the project director.
We don't tell it anything except steer like I do. Learn to steer the way I'm steering right now. Sometimes it keys off of the road edges. Sometimes it looks for the painted lane markings down the center of the road. So it varies, and it learns in different conditions what important features are on that road type.
At slow speeds, the NavLab can use a laser range.
Sounds familiar. This was in the very early 90s. And in fact, NavLab, which is this project from CMU, goes back to the mid-80s, 1986. So people have been working on this problem for a long time, and that persistence should absolutely be celebrated. Now, where are we today? So driverless cars have arrived. A very historical moment happened in 2017. I do think we'll look back in 50, 100 years and see this as a historical moment. And effectively, it was a company, Waymo, deploying fully driverless cars on the streets of Phoenix in 2017. People could use it, people were paying for it, and this was real. Now, there was lots of questions asked from the 2017 timeframe onwards about when is this going to scale? When is this going to be in my city? When is this going to be solving the hardest roadways in the US? If you've ever been to Phoenix, it's a relatively simple place to drive. But in 2021, all of this was answered. All of the doubt was removed because full self-driving cars were deployed on the streets of San Francisco, solving effectively the hardest problem in self-driving. And this is live today. Anyone that visits San Francisco or other US cities can try this. You can go for a ride through downtown San Francisco 24/7, a really historic moment. There's no chase cars here. There's no teleoperation that's watching the vehicle in perpetuity. There's no tricks. This is just a robot that is moving humans through San Francisco. Okay, so one of the most profound benefits of self-driving cars is, of course, safety. If I again told you that you could move entirely in self-driving cars and quantifiably you would be safer as a result of doing so, I'm sure that many of you would want to do that. The roads are, in fact, a very scary place. And the truth is this threshold has been exceeded now. Self-driving cars are quantifiably safer than a human driver. And then the question is, how was this done? And the truth is that there's some very complex pieces of that question, but some very simple pieces. The first is that, in simplistic terms, this was just a grind. People have been working on this for a decade. Issues were found in the field. They brought that data back. They looked at that data. They iterated on it. And you do that process over and over again, days, nights, weekends for a decade. And one day you wake up and the self-driving car can do this. But there's also some other technical reasons why this was possible. If you look at the state of the art in self-driving technology in 2017, 2018, machine learning was applied in large part on almost exclusivity in perception, being able to see the world. As we know from ImageNet and just the abundance of working computer vision, this is an obvious first place to start. But if you looked inside a self-driving cars company's planner or their prediction engine in 2017, you'd likely see lots of rules. And it turns out that these rules do not scale. You simply cannot deploy a safe, reliable self-driving vehicle with that. So what's happened since 2018 until to present day is machine learning has just permeated through the entire stack. The car that you see right here has about 18 models running on it in real time, across a whole abundance of different problems. And it enables the car to not just be safer than a human, but to drive, in many cases, smoother and better than a human. Again, when I look back and think about a lot of the excitement about artificial intelligence, this has in some ways gone under the radar, just given the performance that you can see here. Okay, so the headline here is delivering a product in self-driving is really hard. Many people I talk to in self-driving, they believe that the success of their company is predicated on getting to safer than human performance, that everything becomes easier after you achieve that moment. The truth is that is merely the starting line. Once you have a vehicle that is safer than a human, you've got all of this work to scale this stuff, because this technology is nothing if it doesn't scale. And you can see some examples here. Reliable infrastructure, data offload, acquiring parking lots, car parks, very tough things to do when you're trying to preserve cash and scale very fast. But this is all absolutely necessary to deliver a product, and this is all the work that the companies like Cruise and Waymo are doing today. I do want to share some examples of non-obvious scaling limitations, because I think these are things that I've learned. So this is the first example, and effectively with scale comes a lot of eyeballs.
We turn now to California and a bizarre encounter between police and a driverless car. ABC's Faith Abube has this story.
This morning, this video going viral, showing a self-driving car being pulled over by police in San Francisco.
This is crazy.
The car was pulled over because it was driving at night without headlights on. At first, it looks like an ordinary traffic stop. An officer gets out of his car to speak to the driver, only to discover
ain't nobody in it.
And then the car speeds away from the officers, passing through an intersection. Before pulling over again. Multiple officers then approached to inspect the car. Cruise, the company that operates the car and is majority owned by General Motors, tweeted, quote, "Our autonomous vehicle yielded to the police vehicle and then pulled over to the nearest safe location. An officer contacted Cruise personnel and no citation was issued." Cruise won approval this year to operate its driverless taxis in part of...
Go back a second. So I think this is a reminder that when you're operating in the physical world, where you are interacting daily with tens of thousands of people, even if they're not using their product, they are seeing your product. It just amps up the stakes of scale. It makes it really, really, really tough. If you use GPT and it hallucinates or makes a mistake, well, only you see that issue, right? But in self-driving, everyone sees your issues. Everyone has an amazing cell phone in their pocket that they can pull out and live stream, and all these clips go viral. So that's one example of a non-obvious scale limitation. A second non-obvious scale limitation is humans with negative intent. I don't believe anyone in self-driving predicted this. I think everyone tries to assume the best intent of people, but it turns out that once you start to deploy self-driving cars at reasonable scale, people try to do negative things with it. And you can see an example on the left here with people graffitiing both a Cruise AV but also a bus. But on the right, you see something just absolutely very dumb, Darwin Award type behavior. You see a person sprinting out into the front of one of our vehicles, and this person has actually done this multiple times and continues to do so. So as you scale, you need to be aware of this behavior because it is going to challenge you, absolutely. A third, perhaps more obvious example of scale limitation is to solve for weather. If you want to scale a self-driving service and deliver an actual product, your fleet can't keep going down for weather. It absolutely has to be able to handle these sorts of conditions. Lots of effort has gone into this particular space, and it's a reason the companies are scaling now. Two ways this has happened. One is custom hardware. You can see on the right the comparison between a custom-built radar versus your traditional automotive radar. The custom is on top, and you can see in foggy conditions or rainy conditions, the car is able to perceive the world quite well. In the bottom, obviously not well at all. The second reason this has been possible is good old-fashioned machine learning. Two ways. One is that to be able to, like a human, drive differently according to the weather condition. I don't know about you guys, but if it's raining very heavily, I slow down. If it's foggy, I slow down. And the same thing is now true of self-driving vehicles. So it took a lot of time to get to this point, a lot of time, and many in the industry have aged horribly as a result. But the truth is that self-driving cars are now here, and they are in multiple cities in the US. This is now a really important moment for the industry, where I truly don't think it's long until people wake up one morning, look out their window, and see a stream of self-driving cars come by, especially in London. It's definitely going to happen here. I do think it's worth recognizing that this problem is, as I've mentioned a few times now, it's very, very difficult. It's a very unique combination of machine learning, a physical product, hardware, sensors, interactions with policymakers, cities. I really don't think there's many problems that are harder than this. And I do think it's worth celebrating the many, many thousands of amazing folks that have contributed to this, because this is going to save lives. This technology absolutely will save lives, which is really exciting. And also, I think it's worth noting that many in this room have helped push forward the state of the art in this technology. You may not have worked in self-driving cars, but if you push the state of the art in artificial intelligence in any fashion, I guarantee you it's helped the folks in self-driving get to this milestone quicker than they would have. Just think about computer vision and how far that's advanced. It's very difficult, but it's also very much worth it. You can see a few tweets here just from a rando search I did on Twitter. And I do feel there's very, very few products in life that evoke the kind of emotion that we're seeing in self-driving cars. Just people behind, when they get into a driverless car and people record it, you can just hear their giggles. You hear them laughing, you see them smiling, you just see this like raw emotion. And especially when the vehicle takes off and they see the steering wheel moving, people scream, people shout, people are just so excited to see this. And there's a key word, and actually I used it for the search, but magic. This really does feel like one of those magical technologies that we're all very fortunate to get to try. And the truth is, we're still so early. I mean, I was just talking about this with someone here where, 2023, we're here, these cars are scaling, but fast forward to 2033, which might feel like a long way away, but it's really not. And this technology is going to evolve, it's going to grow, it's going to get more competent, it's going to get more intelligent, it's really going to be incredible. And I put this here just to kind of paint a picture of where we are today. On the left is an open source simulator called Carla, and you can kind of get a vibe for what simulation in self-driving cars, more graphical simulation, looked like in 2018, your kind of run-of-the-mill video game engine. And 5 years later is some really cool work from Wave, a self-driving car company based here in London. And you can just get the sense of where this is going and how fast this really is evolving. It's now happening in cars in US cities, but it really won't be long until it's in trucks, it's in other autonomous systems, it's in flying cars, like all of these crazy cool things. And like I mentioned a slide or two ago, millions of lives are going to be changed for the better by this technology, which is just incredible to think. Okay, so that's it for me. We can jump to some Q&A, but if I have to leave you with one message, it's that self-driving cars are here, they're scaling, they're really fun. And if anyone wants to get access to this and is in the US, in San Francisco, Austin, or Phoenix, you can DM me, find me on LinkedIn or something like that. I'd be very happy to help you get a ride in this self-driving technology. Thank you very much.